We have seen two branches in integration. Okay, so one is approximation and one is through algebraic equation. So we will proceed on this. So we'll proceed on algebraic equation. I believe that approximation we have talked. Whatever we felt that it is sufficient. Okay, so prior to kind of proceeding in integration, okay, so double integration and then we'll see triple integration. Okay, so these are called multivariable integration. So whatever generally people they study in their courses, so that is single integration, single variable integration. Okay, but discussion is going on in the dual kind of double integration. So the, then we'll see triple integration also. I mean, if it is multivariable case, like further we will see in kind of machine learning or artificial intelligence, then n level of intelligence. So whatever we are talking, so we are moving towards artificial intelligence because there the relationship between class, feature, and sample all are nothing but they are vector related and they are multivariable related. So computation will means by nature it would attract vector and it would attract calculus. So calculus we have said calculus is nothing but mainly it has two branches. One is integration and other is differentiation. So integration is addition and differentiation is division or subtraction, whatever. So differentiation decreases the item and integration integrate. So addition it increases the item. So that is the idea. But what is difference between the kind of numeric addition, whatever we do, a kind of number addition, number game, and addition that we do through uh, calculus, or the division, what we do, the numerical division, what we do in mathematics, and the division, that is differentiation, that we do through calculus. So calculus we can say that it is mathematical computation, addition, division, subtraction, multiplication, whatever. Algebraic. Okay, so that is the difference. If we do something in algebra, addition through algebra, if I have algebraic equation, and then we go for addition, if I have algebraic equation, and we go for division, then that is calculus. So calculus is like whatever we do in arithmetic equation. Okay, so one is a numeric form, 1 plus 2, 10 plus 20, and this division, number game, and other is algebraic. Let x equal to 5. If I want to say that, okay, 2 into 2 into 5 is how much? Let x equal to 2. Then 5 into x equal to 10. So algebraic equation, when we substitute whatever we feel that is varying into a kind of xyz algebra, alphabetical, then it comes as algebra. So if we have science in algebraic and then we tend to calculate the addition or division, then we go for calculus integration and differentiation. Like if I take example of differentiation, then in algebraic equation, if I take 2 points, x1 and x2, okay. Now, if these 2 points are independent components, so these are typical algebraic concept, independent component, dependent component. If I say z equal to alpha x plus beta y, then z is computed based upon the value in the alpha x and beta y, then x and y. So z is dependent upon value in x and y. So x and y are independent components, z is dependent component. If I am calculating dz by dx, whatever, differentiation, then x has two values, x1 and x2. At the x1, we have z, x2, we have z. Z1, Z2. So Z1 minus Z2 minus Z1 divided by X2 minus X1. That is the differentiation. That is the division also. Then what is difference between division and differentiation? Division happens in numbers. Differentiation happens in algebraic equation. That is the difference. So there, in the differentiation, there is independent component, there is dependent component. Okay, both places we do delta z by delta x, rate of change in the numerator, with the change in unit change that is seen in denominator. So both places division and differentiation both are same, delta z by delta x. But here, whatever we receive, if it is algebraic equation, normally we receive the result in the algebraic equation. That is the class. If I have differentiation in terms of x, then I can substitute x with any number, and at that point I can see the rate of change. That is the algebra. Algebra means we come up with the equation where we keep changing the independent component and we keep getting the new dependent component. So that is algebra. So science behind calculus is generic. Can we substitute our number game into algebraic equation, and post that we can compute integration and differentiation that will result into another algebraic equation. If it comes in another algebraic equation, then we can just keep changing the independent variable and getting the integral or differential values. Okay, so it is generic. That is the integration and differentiation. Now integration, there are two parts. So if I say delta z by delta x, where delta x tends to 0, limiting the delta x to tends to 0, that will come at dz by dx, that is differentiation. So similar to that in integration, if I have xy plane, so integration is nothing but addition. If I have a algebraic equation, and that algebraic equation, okay, so integration is we are calculating the addition. So if I have algebraic equation, and that algebraic equation is of equation that is rate of change per unit independent variable, then if I calculate the integration, then for the variable it is the rate of change that we get. Like rate of collection, then what is the net collection? Okay, rate of change in some amount, then what is the amount? Rate of change means for what? Rate of change, rate of collection per hour. Rate of x per y, then x into y. If I have x into y, then I get x through differentiation, and if x is the rate of change per unit in y, then x into y, then I get the value through which the differentiation had happened, antiderivative. Now, the way we see dz by dx, that is delta x tends to 0, similar way integration is nothing but calculating the area. If I talk about 2D, where there is x-axis and there y-axis, and there is an algebraic line, and if I calculate the area, then I calculate the integration. So in that sense, we say that area is nothing but perpendicular multiplied by base. So base multiplied by perpendicular. But if it is a variable equation, then we don't have flat perpendicular. In that sense, we cut the equation, the line, into so many cuts. Okay, so each cut we can estimate it as a rectangle. So if I make a cut like this, and then another cut like this, and line is passing like this, then where and I make cut very small, that is delta x tends to 0, then the line that is passing through, probably it will have one or two reading only inside the cut. If there is a line like this is x-axis, this is x-axis, this is y-axis. I have an algebraic equation of a line. So line has a vertical value against the independent component in the x-axis. Now I am cutting the line into so many vertical. Now I take two vertical. It is as close it is very close to each other. If it is very close to each other, even the line is not flat, it is passing in a curve fashion between these two, but it will have 1 or 2 points only inside the inside the cut to give the reading. That is the idea. So it will look like a flat if it has only 2 points. That is when it is entering into the cut and going out of the cut. Only 2 points are there. Then it is considered as only 2 points. I can calculate the average, and it is as good as flat. Then I can calculate the area of the rectangle. So if I make so many cuts, then the vertical will be different at each cut. So one vertical is one area. This way, we can have so many rectangles and we calculate the area and add it. So that is the integration. Okay, this is through approximation. Same way in 3D, if this is XY plane, then on the XY plane, I make so many cuts along X-axis, so many cuts along Y-axis, and I have so many rectangles. There it was vertical cut we made. Here we make cut along x-axis and y-axis, and so many rectangles we make. Now I have equation of a surface. There it was line and it is surface now, full surface. So this is xy plane. On the xy plane I have equation of surface. So surface over a rectangle is like this, somewhere tilted. Now rectangle x and y, delta x and delta y, will make so small that it will have only 4 points. That is bottom left, bottom right, top left, top right. Then I can make it average. So delta x very small, delta y very small. So rectangle is very small. In that case, the surface that is passing on top of rectangle is very small. So then there it was we were getting a rectangle. We calculated the area. Now we are getting a volume. So surface cut, and if it is surface cut, then below is the area, rectangle. Below is rectangle. On top of it, we have verticals. So in that rectangle, how many value surfaces is giving? If I make the rectangle bigger, then surface will be big on that of rectangle. So estimation of the height will not be the perfect. So we cut into so many. So if I say I cut n times along x-axis and m time along y-axis, then total rectangle is n into m. N into m. So n into m, whatever number of rectangles we have, and each rectangle has delta x as width and delta y as width and length, then it is considered as this rectangle has area delta x into delta y. That delta x tends to very 0 and delta y tends to 0. In that case, we get a small rectangle. So above the rectangle, if I see the surface, then it will have very minimal point in the rectangle. So we can calculate average over it. And then width, then bottom area, that is delta x into delta y into the height. That is the volume. So in 3D, we calculate the volume through which we get the net addition. But again, calculus is calculus. So calculus means if I have a surface equation and we calculate the integration, then resultant should be in algebraic equation. If surface equation is algebraic equation, then there is a high chance, if it is polynomial, okay, trigonometrical, then high chance that result will come out as equation 1, algebraic equation 1. In that case, now it is in form of x and y. I keep changing x comma y and keep getting the integration. So integration is calculation of the addition over a certain area. In 3D, in 2D, calculating the addition over a certain period along x-axis. Here, along certain area along xy plane. So that is the 3D integration. Okay, so this is one way of calculating 3D integration. Other way of calculating the 3D integration, since we are talking about, so what we talked here, that we will make cut and we see the equation, average the equation, but it is typically this form of approximation. It is in use. It is not in use. Not the case that it is not in use. Like if we go for contour kind of diagram, we gave the example also. If we are calculating the volume of a hill, what is the volume of a hill? where a hill is slope is like this, or volume of a pyramid, where if I make cross section along z axis, then from top I can see different height and different circle. At different height, we see if I make a top view and make a cross section, then at different height we see different area. So that is the contour diagram. So if I have contour diagram, then if I want to find the volume through contour diagram, I don't have equation in a such a way. Then, so we talked about algebraic equation. So in case we have contour diagram where we have height, based upon each height, we have surface area, then we can go for approximation. Can go for approximation in the equation also. But there are better way to do for the algebraic equation. So one idea is approximation. Now the other idea is through algebraic equation. If I have algebraic equation, then let's go through algebra one, because I know few things now, that integration of t to the power n is t to the power n plus 1 by n plus 1. So with this equation we can derive higher level equations also. So calculus starts from algebra addition and it ends at algebra equation. It's a science of algebra. In mathematics, if we see the division, diversion, then okay, numeric game to algebraic game, then calculus is a game that we get in the algebraic way. So we get the addition, but in algebraic region. Now, suppose that if I have a surface like this, xy plane, and then we want to calculate, kind of. So in 1D, we talked about 2D. Now in 1D we calculated the integration. Okay. Now in 2D, so integration in 1D when we have a xy line. Okay, so if I have x-axis and there is an equation like this, and if I calculate the area, so in this surface I calculate the area. So we talked in the okay, that is 2D, means I have a one xy plane. But in 3D, where we have xy plane and this is z-axis, so if we calculate the integration like this, then then either we can go like this, calculate the surface. So if it is x-axis, if this is x-axis, then this is xz plane. X-axis, xz plane. Y-axis, yz plane. So xz plane, if I do the integration, then in xz plane I calculate the area. Okay, so I can keep calculating the xz plane, all the area where at each area y is constant. So if this is x-axis, this is y-axis, then at each y we calculate the area in xz plane. Whatever the area comes, so area we will make sure that it is a algebraic equation. So with function over y. If that is the case, then whatever the area I receive, so if I keep changing y, then keep getting the area at each y. That is the idea of algebraic equation. So if I keep changing independent variable in the equation, I keep getting the dependent variable. So whatever the area I am calculating in xz plane, if I keep it as a function of y, then at each y I can get the area. So this area multiplied by this y length will give us volume. That is what we want. Or if we have in yz plane, if I calculate the area, then area will be as a function of x. So this area multiplied by x value, then it will give the volume, whatever we want. Now we went for example, like if I have a semicircle, okay, if I have a semicircle, okay, and semicircle is kept like this, then the base is x-axis. Okay, so the base is x-axis and this is, and at the center, if this is the center, then this is y-axis. At the 0 0, this is y-axis, this is x-axis. So if it is semicircle, then the flat region is x-axis, and and in between this is y-axis. So it is kept like this on the xy plane. If it is kept like this in the xy plane, then z value is y. This is what we discussed. So at the x-axis, z, okay, this is better. So at the x-axis, the height, the z value is the y value. So y value is 0. But as we go along y, z value increases. So when we have at y, that is the radius, the z is the radius. Otherwise, it comes as 0 when y is 0. Whatever the y is, that is the z value. So z is equal to y. That is the equation. Now we have to calculate the volume. Now suppose the radius is 3. Then if this is origin, this is minus 3. This is plus 3. And this is along y axis 3. Now the equation of this, we can say the circle is x square plus y square equal to radius square. So y square equal to 9, 3 to the power 2, 9 minus x square. So y equal to 9 minus x square square. Now we will have first in the yz plane. So we will calculate in y area. So if we want to calculate along y area direction, then we'll take we'll calculate the area in yz plane. So yz plane we calculate all the area, then multiply into the x direction. So in yz plane, if I take, then it will be in the function of x. So y equal to 9 minus x square square. So if I calculate the area, okay, in yz plane, then it will come as y dy. So the integration is double integration. Double integration. First we have to calculate the area in terms in what plane. So if I calculate the area in yz plane, then it will be integration in dy. Okay. Then whatever comes, then again we calculate, multiply in x-axis, so again integration with the dx. So one integration, and then whatever function we have, fxy dx into dy, or fxy dA. A is area, fxy is the height, fxy is the z value. So height into area is the volume. fxy is the z value at any point x and y. At that point, if I take a small distance or small region left and right, that is delta x, and and top and bottom delta y, then area around the xy, small area around the xy will be fxy, that is the height, into the down the area, that is dx, delta x into delta y. So delta x into delta y, whatever the rectangle we are getting, area is delta x into delta y, multiplied by at that point xy, fxy. So fxy into delta x into delta y is the volume at point x comma y. Now x comma y, first I'll integrate into y direction and then I'll integrate into x direction. So double integration. Okay. Now we have now chosen to calculate dy first and then dx later. So fxy dy first will settle down, whatever it comes. So it should come as a function of x. Then whatever function comes, then dx. So double integration. So fxy is y. So y dy, integrating it from, so y is 0 at the base and another y is so y is variable with x. So if x is 0, okay, so if x is 0, what is the, so y slab in yz plane, we are taking like this. Remember, okay, if we are taking like this, then when x is 0 at the center, okay, then area is maximum. When x is 3, minus 3 or 3, then area is very small. So, okay, that is the concept. Now, if I say y dy and integration, so base is this. Okay, if this is the semicircle, and then y is 0 along the base and y is maximum here. So 0 to here, but it should be in variation of x. This is what we are talking. So y equal x square plus y square equal to 9, then y equal to 9 minus x square square. If that is the case, then we will integrate from base 0 to 9 minus x square square root y dy, because y means that is a z value. Z value at x axis is 0 because z is nothing but y. The way we go along the y axis, z value will increase the way y is increasing. That is the concept. So z equal to y means here z is 0 and it will grow up till here. Okay, so z will grow from, if it is x axis, then z will be 0 here because z equal to y. So as y is growing, z will grow like this. So this is 3D. Then what is the volume of whatever we are imagining now, whatever we are seeing now? So y dy and integration is 0. So here, okay, so we are taking yz plane. This is the area we will calculate. From y direction, y is 0 until y is here. Y is not 3 here. Y should be in variation of x. That is the concept. So y equal to 9 minus x square square. If x is 0, so here x is 0, here minus 3 plus 3. If x is 0, then here the y will be 9 square minus x square. Anyway, it will come as 3 only. This is what we are thinking. If x is minus 3 or plus 3, y is 0. 9 minus x square square. So here, at this point, on x-axis, anyway, y will be 0. So it is same thing. Now, calculus is a science of algebra. This is what I am saying. So, y dy 0 to 9 minus x square. So, 0 to 9 minus x square, if I then y square by 2. Y square by 2, 0 to 9 minus x square, upper limit only will work because it bottom is 0. So 9 minus x square by 2. Now then we will integrate along x axis, along x. So if we integrated the in yz plane along y axis. Now whatever came as a variation, so it came as 9 minus x square by 2, means the area of in yz plane is 9 minus x square by 2. If x is 0, then area is, if x is 0, the area is maximum, that is 9 minus x square. If x is 0, then it is 9 by 2, 4.5. If x is minus 3, then along this, so here yz, okay, so here yz will be smaller. It will become big here, center, and then become smaller. So it will come as 0. 9 minus x. X is 3 or minus 3, then area is 0. So yz, we have calculated the area at each x. Now we multiply by x, when we will integrate with the dx. If that is the case, then 9 minus x square by 2, we integrate with minus 3 to 3. If that is the case, since x, okay, so integration of 9 minus x square by 2 is 9x minus x to the power 3 by 3 divided by 2. Now x and x cube all are odd. So if I go for this, then they will result in in their sign only. If it is even, then negative and positive will become positive, but it will retain the sign. In that case, 3 to 3 minus 3 is the limit, then it will double it. So it will come as 9x minus x to the power 3 divided by 2 will go away, because minus 3 to 3 we are doing the limit. So 9x minus x cube by 3. So 27 minus 9, that is 18. It will come as 18. So 18 is the volume. Now let's go with the x-axis first. We went with the y-axis first. Let's go with the x-axis first. The equation is y. So y dx and integration, whatever we get, then that with the dy. Now if I calculate the integration first with the dx, then we have to bring it in the limit that is a function of y. Earlier we got in function of x, now function of y. So if this is the semicircle, then we are calculating this area. This is in xz plane. If this is in xz plane, then it should be in variation with it should be function of y. Y should be independent component. And then we have to calculate from this point to this point. Now it is not minus 3 to 3. Okay, it should be in function of y. So x square plus y square equal to 9, that is the equation. So x equal to 9 minus y square root. If y is 0, then x is 3, but we want it minus 3. If y is 0, then x is plus minus 3. Then now y dx is the integration. Earlier we had y dx dy, but we took dy prior. So y dy we integrated. Whatever it came, then with the dx. Now y dx will do, and whatever is comes with the dy. So y dx, that is the integration. So it will come as yx. Okay, y is constant. So yx. Now limit is minus 9 minus y square square root to 9 minus y square square. Okay, x square plus y square equal to 9. Then x equal to 9 minus y square square. So one side is minus 3, means minus 9 minus y square square. If y is 0, then that should forcibly come as minus 3. If 9 is 0, then this side forcibly it should come as plus 3. So minus 9 minus y square square root to plus a square root of 9 minus a square root of 9 minus y square to plus a square root of 9 minus y square. So yx is the integration. So it will come as okay. So it is both are again same. So it will come as kind of okay. So y into x. So y into square root of 9 minus x square. Okay. So y into square root of 9 minus x square minus, okay, and then again minus, so it will be plus square root of 9 minus y square. So that will come as, okay, 2y square root of 9 minus y square. Okay, 2y square root of 1 minus, sorry, 9 minus y square. Okay, so it is, now we will again integrate with the dy. So 2y square root 9 minus y square. Okay, so this is coming as antiderivative. Means if I need to calculate the square differentiation of 9 minus y square, 9 minus y square to the power 3 by 2, then it will come as 3 by 2. I have to take this side. Then 9 minus y square to the power 1 by 2. Then if I do differentiation again, then it will come as 2y. So y into a square root of 9 minus y square it will come. Okay. So antiderivative if I take, then it will come as 9 minus y square to the power 3 by 2 in that terms. Okay, now you can calculate it, and now the limit. So we are calculating dy now. So when we calculated against dx, then it came as 2y square root 9 minus y square. Okay, now when we are integrating now with the dy, the limit is 0 to 3. Now it is constant. Earlier it was 0 to 9 minus x square root. Now, and x was minus 3 to 3. Now, first we are integrating it is as a function of y, then minus square root 9 minus y square, 9 square minus y square square. These are the two limits. With these two limits, we came to 2y square root 9 minus y square. Now, if I integrate this with the dy with the antiderivative, it will come as y into 9 minus y square root will come as 9 minus y square to the power 3 by 2 with some constant. Okay. Now the limit what we will place. So we are calculating the integration with the y-axis. So from 0y to 3. Okay. Please calculate it. It will be kind of I have to remember the values, but this is the how it is. So we will see. So that will come as some constant into, as per the anti-derivative formula, some constant into 9 minus y square to the power 3y, where the limit is 0 to 3. Okay, it should come as 18. So either we calculate fxy dx dy or fxy dy whatever we do first or second doesn't matter, because volume is same. Okay, so this is the way we are calculating the volume, the kind of uh, the so two way we calculated the volume. One was we took the area and we put so many rectangles, and then through approximation we calculated the value volume. Or if I have area, then we calculate two. If I have xy plane, then we calculated yz plane rectangles, and then we multiplied by x, it gave the volume. Or in xz plane, we calculated the area and then we multiplied by y, then it gave the volume. So one side it gave 18, other side we came to equation that we have to now put the limit 0 to 3. It should come as 18 only. So these are the two methods that we see. We'll proceed further to the triple integration. Okay, so this is double integral, where we have the two independent component along a surface and dependent component is vertical. Then we calculate the area in one plane and then multiply in other direction, or calculate area in other plane and calculate the multiply to get the volume. So this is double integration. What if I have kind of three independent variables? This will come as 4D, 4D, three independent variables. If we have three independent variables as x, y, z, then we have fx, y, z, function over x, y, z. In that case, how we will calculate the volume, that we will see. Okay, so that is the concept. So be ready, I would say. So, as I always say, that mathematics is a science of step by step. So if you follow step by step, it is the easiest and the most enjoying. Otherwise, it is like a nightmare.